I think we all know that South Africa is very heavily energy constrained. We feel this on a daily basis, with load shedding, with impacts on restraints of growth, etc. What we don't often think about is how closely interlinked water and energy are. In fact, the fortunes of water and energy in this country are tied to the same masthead.
The Conduit Hydropower initiative in the WRC had a very small beginning. It started with a very small study, which its background was in the 2009 load shedding effects that we faced in South Africa. This idea suddenly cropped up as to why we are not using the excess energy in many of our distribution systems to generate energy. So through the WRC, I took the initiative and issued a very small study, a scoping study with the University of Pretoria under Professor van Vieren and his student Marco van Dijk, and threw this challenge to them and said, let's see the potential of conduit hydropower.
Based on the Engineering Council of South Africa's 2012 report, the University of Pretoria graduates about 30% of South Africa's civil engineers. Utilizing their expertise was essential to the project.
We are honored to be a partner in developing South Africa's first small-scale hydropower system to generate hydroelectricity.
In our country, most of the water supply is either pumped to break pressure tanks or big storage facility, and from there it gravitates into the network where it's been utilized by the consumers. The opportunity then lies in the fact that you've got a varying demand, and during periods where there's no specific high demand, you can actually utilize the high pressure to generate electricity. In this case, we talk about then conduit hydropower.
A hydropower plant was also constructed on top of a reservoir in Pretoria, or city of Tshwane. It's called the Peer van Ryneveld Conduit Hydropower Plant. It's a very small unit, only 15.8 kilowatt can be generated at this specific site. And at this specific site, the energy is used to provide electrical fence for protecting the site against vandalism, lights, telemetry, and so forth. The site is situated in a security estate, and the estate owners have also shown interest to maybe use some of that electricity for lighting in the streets in the security estate.
As we completed that, we also followed up at looking at micro and pico hydropower units, etc. And in Durban, we implemented 2 very small pico units.
This is one of the technologies that we used in eThekwini Municipality in Durban. This is a Pelton turbine, only a 1 kilowatt. The water would enter the turbine through this pipeline. It will be forced through a nozzle. The nozzle then increases the velocity that hits the buckets, and that would in turn turn the turbine. The water from this would then fall straight into the reservoir through the opening here at the bottom. A very small unit, but there is still application for that in the conduit hydropower environment.
With the success of the smaller scale units in Tshwane and eThekwini municipalities, it was time to expand. And that's when Bloem Water from Bloemfontein came on board.
Research is very important in the world of water. As you know, that Bloem Water, its core business is to supply water to communities. Therefore, it is important to be in par with the recent developments.
Based on a study done by the University of Pretoria, Bloem Water decided to pursue the implementation of a hydropower plant at our Brandkop Reservoir.
Our water supply system, which is the Velbedacht water treatment plant, water supply system, has the potential to generate energy. The plant is situated 120 kilometers from Bloemfontein, and along the way there are 3 reservoirs: the Hoek Reservoir, 8-Gig Reservoir, as well as Brandkop Reservoir. The potential to generate power was established at both Brandkop Reservoir as well as 8-Gig Reservoir. And this potential is about 300 to 400 kilowatts. And it was established that a turbine to the size of 96 kilowatts will be sufficient to generate power for this particular initiative.
The turbine that we use here at Brandkop is a standalone turbine. That means that we are not tied to the grid, to the Eskom grid. And the electricity that we produce out of the synchronous generator that is connected to the turbine is in use for the Bloem Water office only. The process we follow is that the main line that comes from Welbedag Dam is dissipating the water into the Brandkop reservoir through 5 control valves. With it, there's a lot of pressure in the pipeline, which contains then the energy that is going to be dissipated in the reservoir as well. To make use of this energy, we decided to take a part of the pipeline. We rerouted that to the hydro turbine, and it goes through the turbine, and that drives then a generator. The synchronous generator produces then the electricity, which is going to be used by Bloem Water's head office only. The water that comes out of the turbine actually goes back into the reservoir via a channel underneath the turbine. And there's no contamination whatsoever into the water as such.
The cost associated with each of the components, the turbine was about R1 million, electricity was about 800,000 rand, mechanical was about 700,000 rand. In total, the project cost is about 3.5 million rands. The payback period is estimated at 7 years. In order to ensure that we have first-line maintenance during operations of the system, 2 of our electrical technicians were sent to Italy, IRM, to learn more about hydropower as well as maintenance of the turbine once it's been delivered to South Africa for use.
We like a situation where we retain our expertise. Therefore, you know, the only way it doesn't matter what you do, but the only way you can retain your expertise is to continuously improve them so that they also become competitive to global and local needs.
With a deepening energy crisis in South Africa, hydropower is now, more than ever, a viable option to supplement the increasing need for electricity.
If many of our metros, if many of our municipalities tap into this opportunity, it would go a long way in reducing tariffs, in reducing dependency on the national grid.
We think there's a lot of potential still in the country relating to dams, the release from all of our dams. We've been involved in some of the studies. Ebenezer Dam for Lepelle Water Board was one of the opportunities that they're still considering to implement. And there's a host of other opportunities in South Africa.
In conclusion, Conduit hydropower is power that utilizes existing infrastructure for power that is freely available at a low implementation cost.
In summing it up, this has been a very exciting journey, a very good learning process. And the important thing is that through this process, we are able to make a difference in society. We are able to make a difference to the country and contribute in a big way. And what we've done till today is a very small indent into this whole opportunity.
Tranquility Base here. The Eagle has landed.